so I'm not exactly sure how to deliver this. It's gonna be hard because this is this is online, and I'm trying to make it as interactive as possible. But hopefully we are able to achieve the goal for today. So we have about 1 hour, and so just I'm just going to tell you how this entire thing will be structured. I'm supposed to be giving a short presentation on dependency injection. It is my understanding that you guys have already learned about dependency injection before now. I heard that it was kind of like taught in class or something like that. But if you have any questions, if it was not clear at any point in time, so any single thing you need to clarify or ask, you can always ask me. Like, feel free to cut me short right in the middle of when I'm talking. Like, feel free to just say, yo, I have a question or I don't understand. If I am speaking too fast, let me know. If I am not speaking audible enough, let me know. Um, yeah, so that's it. I am going to just be giving a rundown of what dependency injection is. And we are going to try our hands out at a very contrived example. Like, we're just going to come up with a story, a scenario, a story, and then we're going to, just write some code for it, right? And at the end of the day, you should be able to see, at least the objective of this is that you should be able to see the benefits of using dependency injection. So at least you'll be able to see it firsthand. All right, so um, give me a couple seconds to figure out where my slides are. Sorry. Just give me a minute. Okay. I think I have it over here. Let me create a new. I'm gonna move this over. X. Okay, so I'm gonna share my screen, and we can start. So, how do I even present this? Oh yes, right here. Oops, sorry, wrong slide. All right, cool. So like I said, I want this to be as interactive as possible. So I'm gonna start by asking you guys some questions. Maybe who can give me just a simple, a straightforward statement about what they understand about, dependency injection. So, like, so far, like I said, I understand you guys were in class and you guys were taught dependency injection. Maybe you can give me like a single statement, or just give me your own view of what you think dependency injection is. Maybe starting with you, Taiwo. Can you guys hear me? Okay. Taiwo.
Yeah, I can hear you.
Okay. So I was saying, maybe you can just give me just a single statement or just a simple explanation of what you understand dependency injection is.
Okay, well,
Or any information you were able to get from the class you had on dependency injection.
uh, it's yesterday, but I wasn't really feeling so well. So, but I was trying to actually go through the video again today.
Okay.
Yeah.
All right. That's fine. That sounds good. What about you, Olamide? Do you have any idea?
Sorry, I would say dependency injection sort of just like the name, like dependency injection. You have maybe modules or other components or sort of other things that you need in another part. So probably your can you get me?
Yeah, it's kind of hard to hear you. It's kind of hard to hear you, but I think you're on the right track. I think I'm getting
Okay,
you.
I was saying like probably you have a structure or the code with various components and at some point or in different components you need one part of the code or one module or one component. You can just inject it or you can add it, you can dynamically put it into the component where it's needed or something like that.
Yeah, yeah. That is actually spot on. That is what it is in a nutshell. Jimmy, do you have uh, any explanation from your end what you understand dependency injection is?
Okay, in simple terms, dependency injection is basically just a design pattern that allows you to create an object outside a class, and it gives you a means to provide those objects to another class. Different ways to provide the objects.
Yeah. So yeah, you guys are actually spot on. That is what it is. Uh, before I actually add to what you guys have said, I think maybe I should just introduce myself. I didn't do it properly. So yeah, my name is Efeturi Money. I have been an Android dev for the past 4+ years. I started just immediately after school. Uh, I finished from the University of Ibadan actually, and I started Android. Actually, funny thing is, I started Android while I was still in school. When I was writing my project, I had this friend who was, dabbling into Android, and it seemed kind of cool. And he sent me this link to like Udacity, Udacity.com. Back then, they had like some free beginner Android dev courses, which I took. So I don't think Udacity is still free at this point. They have this whole nano degree thing now, and but I'm not sure. I'm not sure, to be honest. I haven't checked it in a while. But yeah, just after school, I was super lucky to get an opportunity to work with Marquesian in Hotels at NG. Till today, I don't even know why Marquesian gave me a job, because the app that we built did not even see the light of day. So it's almost as if he gave me a job for Holy Ghost's sake. But thankfully, it was good, because that kind of like gave me some practice on Android, some chance to like learn. I was supposed to be in NYSC service, but I kind of like ghosted the entire service to work at Hotels Denji, and I don't regret it at all. From there, I moved on to eTransact, And then from eTransact, I went to join Conga in 2017. And after Conga, laid off 2/3 of the workforce. I was part of the people that got laid off, and I tried my hands at, interviews abroad, and I finally got a job working at Karim. So that's basically it. For the other side of me, I'm also a very diehard gamer too. So you can usually catch me playing FIFA and Apex Legends, which is like a battle royale kind of game. And I really, really like Kotlin, the language. It's amazing. So yeah. A small word about Hotels.ng. I think Hotels.ng is running an internship series. I think they do it I'm not sure if it's every 6 months or if it's every year, but I have a lot of friends that have gone through the internship and have come out like with some level of technical skill. So if it's something you guys have done or you guys are interested in, I think it would be good to just try your hands at it. I think it's a remote internship, so you don't have to be there. You just have to get in and join others that are also learning, and get some programming, work under your belt. So that's about me. Like I said, at any point in time, if you want to like stop me, ask me questions, please feel free to interject, and I should be able to answer your questions. So yeah, you guys have said it all. Dependency injection, put very simply, and I say very simply because when you understand how simple dependency injection is, you would really not think twice before implementing like dependency injection, because it's pretty simple, and it comes from somewhere actually. Or put simply, it is making sure that a class or an object that you've created does not know about how to create its own dependencies, things like services and other stuff that this object depends on to do its work. So I mean, in classic OOP, you create objects, or you write classes for a reason. Every object should have its reason. So a string, for instance, it's supposed to be like a series of characters. If you build an object and you say the name of this object is a water heater, then its function should be to heat water, right? So every object has its responsibilities, but sometimes every object might need some other object or some other class to be able to do what it needs to do. So for instance, if you are in an Android app, sometimes you would need to ask the system for a layout inflator, or ask the system for what is called a vibrator service, which you could use to like vibrate the device. You could ask the system for NFC or Bluetooth, which you would use to communicate via Bluetooth. So that is a dependency. You are depending on the other class for your own functionality. So right. So dependency injection just means that a class should not know about how to create its dependencies. All those dependencies should be passed into the class. Like that is the long and short of dependency injection. And the reason why we need that is because we want to write maintainable software, right? So there are a couple of principles that aid us in reasoning about and also writing maintainable software, right? So we have the solid principles. And for some of these things, you can like look them up. This is not an exhaustive list. It's just 3 things that are actually related to dependency injection. And one of it is solid principles, which is a group of principles that that help you to design classes and the interaction or the communication between other classes, right? Dry just means don't repeat yourself, which is just a common sense way of saying just don't have like duplicated code all over everywhere. I mean, so let's say in the case of going back to the example of the water heater. So let's say in your application is a restaurant application, right? And you have like different waitresses, and each one of them wants to like heat water. So every single time nobody would say, okay, every single waiter carry your own kettle, and every time you want to heat water, go and heat water. No, there would be one like either machine or one single kettle that every single waiter, when they want to heat water, they're going to go there, they're going to heat water and take their hot water. So it's not like every single waiter has their own kettle, and when it's time to heat water, they're going to put their kettle and say, okay, I'm heating water, and everybody's heating water. It's a waste of resources. You are wasting a lot of power for no reason. Sure you get. So that's just a simple analogy to dependency, to don't repeat yourself, right? If a class, there's a saying that goes, if it looks like a duck and it quacks like a duck, then it's probably a duck. Basically, if you have the same piece of functionality duplicated 3 times, 4 times, 10 times all over your code base, the exact same piece of code, like the responsibility is the exact same, then they probably should be encapsulated. They probably should be brought together into a class, a function, or something, and then called from each of those places. And the reason you do that is because software changes a lot, right? Requirements change, business logic, business decisions change. So you have to write your software, and that's why the title of this page is writing maintainable software. You have to write it in a way that when it's time to change, it is easy for both you and whoever needs to do the change to change it. If you have the same piece of code in 20 different places, some of those places you don't even know where, because software also has a tendency to get very, very big. So that's why you can't have one person working on a code base with like 20,000 lines of code, because it's a lot. 100,000 lines of code bases. So yeah, like I was saying, if you have a single piece of logic duplicated like 50 times, 100 times, it's so hard when you say, okay, you know what if we want to change this from A to B? When you say you want to change it from A to B, you're not saying, oh shit, I didn't, to the manager, to the product manager, or to the CEO. I mean, you just want to change it from A to B. How hard could it be? But to you, you're thinking about it. Whoa, you have to change this from A to B in 20 places, in 50 places, in 100 places, sometimes in 200 places. Why? Because the code base is so huge. And if you think code bases cannot be this huge, you should really see like banks. Bank softwares are just unnecessarily bloated. Like it's crazy the level of bloat you can see in software. So that's why all of these principles they basically help you write maintainable software. And maintainable just means that over time it's easy to make changes because things will change. That's the only thing that is constant. Actually, people say like the only constant thing is change, and that is especially true um, in software. So again, as part of that, I've already mentioned one of the reasons why you would want to do dependency injection. But these are more technically sounding reasons. So the first one, objects should be independent of how their services are created. And the reason this is important is because, like I said, when the time comes to change, it's much harder to change like you would not want to have to change the internals or how the object works just for so for instance, if every single waiter has their water heater with them, when you want to change that from an iron kettle, right, to an electric heater, you'd have to go to every single waiter and change it for every single one of them, right? That doesn't make any sense. But if every single waiter depends on one single iron kettle that is on a stove in one place, right? You just go to that iron kettle that's on that stove, that single one, you change it to an electric kettle, and all of a sudden, every single waiter has access to an electric kettle, right? So at this point, I just want to ask, does the analogy make sense?
Yeah.
Well understood.
All right, good. That's actually good to hear. I was afraid this was not gonna, but I'm glad you guys are a bunch of smart guys. So kudos. Anyways, the second point also alludes to all we've been talking about. Objects, your classes should be flexible and they should support configuration, right? If you go back to our restaurants and waiters and kettle analogy, uh, I mean, if possible now, let's say every single waiter had an instance of a kettle, and that kettle and they wanted to be able to configure the kettle to be able to boil not only water but to be able to boil juice. It doesn't make too much sense, but I mean to be able to boil tea, right? To be able to boil agbo. So I mean, again, you have to go to every single one of them and say, you know what, okay, you add this thing now, and now you can boil. Go to this one, you configure it somehow. It's at the end of the day, it's just playing around the fact that things can and will change, right? And when they change, your software should be flexible enough to support this change or to support like configuration so that at any point in time you can say, okay, you know what, instead of having a heater, instead of having a water heater, even if it's just if it's a kettle, maybe we should try it with plastic. Who knows? Maybe the plastic will not melt or something. Also, objects should be reusable. So this is just this is concerning the don't repeat yourself pattern. When you have the same logic duplicated in a lot of places, it is better if you have just one, and then you can pass around this class, like one definition of that piece of logic. It could be a class, it could be a function, just somewhere, and then you pass that around. And at that point, it is kind of like reusable. You can take that piece of logic and put it in another place, and this new place is gonna be able to use this piece of logic very fine, right? And then lastly, objects should be easily tested. Um, and I'm not sure if did not check the I did not check the curriculum, but and I'm not sure if you guys have done anything or learned anything relating to testing. But when you write software, you should also test your software. And testing software in this case is not manual testing that you say, okay, you know what, I'm going to type into my stuff and say, you know what, when I put ABC here, I'll see what's happening at this other side. That's manual testing. But I'm talking about writing software to test your software, right? And the reason why this is good is because as going back to our previous discussion, really, software is really complex, and it solves for big software, for a lot of like no software solves like trivial problems. If you wanted to do 1 plus 1, if 1 plus 1 was the only problem you wanted to solve, right, you would not go and write an application to output 1 plus 1. You would use a calculator, right? But most software these days solves they solve a lot of smaller problems, but when pieced together, actually solve a big problem, and it's kind of complex, right? So you, as a human being, to be able to test all the scenarios manually, like all the scenarios. So, and using the context of Android development, if you build an app and you publish your app, right, your app is going to be used by literally people from different backgrounds, people from people from all walks of life, right? You're going to have a small person using your app, you're going to have a big person using your app, and each of them is going to, they have their own background, they have their own, the way they think, they're going to view your app differently. Also, people are going to press your app differently. If a baby picks up your app now and presses back, 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 uh, I mean, anyhow, and your app crashes, like, so basically there's a lot of stuff you need to test and to manually spend all of the time. I mean, we are software engineers, we are lazy, right? We don't want to manually say, okay, if I put A here and say, okay, cool, that's fine. If I put B and say, that's fine. If I put C. So sometimes you write software to test your software, and to make it easy for yourself to be able to test your software, um, you use dependency injection. Why? Because it is flexible, it supports configuration. And what that means for testing is that for all of those dependencies, you can swap them with test dependencies, which is basically just, something, something that you can, something that you can set up like examples for, right? So a test dependency, if we use the analogy of a restaurant with waitresses and with waitresses with kettles, right? You can say, okay, how how do I want to test this? Uh, how do I want to test my restaurant? I want to test how my restaurant works when the kettles have metal handles instead of plastic or wood, right? So again, if you have 1 million kettles, if you have, let's say, like 20, 50 kettles, you'd have to go into each one and then say, okay, you know what, how is this waiter going to, I mean, it doesn't even make sense. If you have just one single point to change that kettle, you can say, okay, cool. I'm going to set up this kettle with an iron handle, right? And let's see how they this thing. And then you notice that, oh shit, whenever the waiters go, the handle of the kettle is too hot for them to do anything with it. So okay, iron handle does not make sense. You don't have to, do it across like every single one of like all of the instances of the kettle. It's a very contrived example. It's a very, anyhow example, but hopefully it kind of like drives the point, which is just objects should be independent, flexible, support configuration, reusable, and be able to be tested. So for testing, I mean, if you haven't done anything related to testing, that's fine. But just know that later on, if you are actually using dependency injection, later on when you start, writing tests and when you start testing your software, it's you're gonna see the importance of dependency injection, right? So, cool. So now we've said, okay, this is what dependency injection is. It means that as an object or as a class, as myself, I should not know how the things I depend on, the services, the other classes that I depend on, I should not know how they are created. I should just be giving them, and I'll work with them, right? So actually, there's another analogy I can use too. which is basically just if you have a small child, right, and you want to feed the small child, you don't tell your small child, oh yeah, go to the pot and go and dish the food, right? Your child can go there and just mess up the place or do something. No, rather you tell them, what, sit down here, wait here. This is the food. Take, eat. So the job of your child at that point is to eat the food, and it's somebody else's job to take that food and give it to your child and give it to the child, right? So the section that we are in now is, okay, how can I dependency injection? How can I do this thing? And in the Java world, uh, you have very few ways of passing things to an object, right? So one of it is via constructors. So when you are constructing an object, when you're creating an object, you type, new water heater, right? New car, new solution class, new whatever, right? You call the constructor of this class, and in the constructor, you can define, parameters that the constructor takes or that this class takes. So that is a way to pass objects or services or whatever it is you want to pass to a class. And it is preferred, and it is also the earliest possible time you can pass a dependency or an object to another object, right? Via constructors. The next way you can also pass an object to another is via fields. So when you have a Java class, the Java class is made of fields and then methods. Methods could be constructors. They could be other methods that are not constructors that take parameters and all of that. You can, for fields that are accessible, right? You can always assign them something. You can say, what, object dot field is equal to this. You can assign it, so you can pass an object via the field. And lastly, you can also pass it via a method. So you can say, what, object does set dependency, set this, and you pass it what you want to set, right? And we're going to see an example of all of this in the next section. So at this point, I hope we kind of like have a good idea of what like dependency injection is.
Yes.
Yeah.
Cool. So let's take a very contrived example. So so I have this project. It's I if I understand correctly, you guys have been writing Java all through.
Yes.
So okay, cool. So you are more comfortable with Java. Or if it doesn't really matter, I could also write Kotlin. If you want to see some Kotlin, I mean, you choose. If you want to see some Kotlin, say I.
No, it matters actually. I don't want to see any Kotlin.
Good. Sounds good. So, okay, so this we're going to tell a story, right? And this story is a construction story. So, actually, it's not a construction story. It's an Uber story. It's a Karim story. It's a anything story. So you have your app, right? Again, this might not sound like it makes sense, but just follow me. So you have your app, right? And your app is an app that provides drivers. Let's say, so you have drivers, right? Let me create a new class. Yeah, we're going to create a driver class. And your driver can also always drive a vehicle. Oops. Kotlin. Right? Your driver is able to drive a vehicle. So, actually, let's do this. Your driver is able to drive. So let's also create a run class, and this class is only static void main. Its only job is to run our app. So let's say we have a driver. Let's say we have a driver, and we can driver dot drive, right? Cool. But then, I mean, your driver has to drive something, right? So let's say we create our car, for instance. Actually, we can give it its own type. So let's just create a car. And this car can be driven. So let's just say so we can ride a car, and it will return the amount of the distance that it was ridden for. So let's just say 0 for now. Cool. But I mean, this car also needs to have an engine. This car needs to have an engine. So let's just say it will probably have a chassis. Do you know what a chassis is? Do we know what a chassis is? A chassis is just like the body of the car, right? Let's say it has a chassis, or let me just call it a frame. The car has a frame. The car also has it has seats, right? The car has seats. So let's create an engine. Again, this is a very contrived example. Let's create a frame. Let's also create seats. But this time, the seat is going to be an enum. And actually, no, let's not be an enum. Let's just be a class. A seat, and a seat has a position, right? So I mean, when you're defining this, you can already see that this is getting although this is just like the model definition. This is just like how you're modeling it. So you need a car, right? you have to set a car dot engine is equal to you know, new engine. Actually, this engine, let's say it's a V8. It's a V8 engine. So for now, your car only supports a V8 engine. Oh, okay. What? Oh, that was the wrong refactoring. Yeah, we can alt enter rename file. Yeah. So your car only supports a V8 engine. So you have to supply a V8 engine. Your car has to have seats. You know what, for now, we're just gonna give it just one seat, right? Cool. And then now, after creating your car, you can now drive your car, or you can now ride your car, right? So, I mean, if engine is null, we want to throw a new exception. What's the same? Unhandled exception, okay. Yeah. And finally, if seats is null, or seats dot size dot length is equal to 0, cool. Is the text too small? You know what? Don't worry.
No, it's all right. It's all right. You can see.
We can see.
You can see. You can see.
Breeze go blow you and everything.
All right. Cool. And then, let's just say we return engine dot mileage, the current mileage. Yeah. So cool. We have created a few actually also. Let's say seats at let's say we're sitting on this one, the position. Okay, no, let's just leave it like this. I wanted to add a condition that that you must be sitting down to write it, but I mean, again, it's a contrived example. So you want to write this? What does this say? And so now we try catch. Let's see if we throw E, what will happen? We need to handle it. Okay. Actually, we're not gonna do try catch. We're gonna add the exception to the method signature, and then we'll try it and catch it later on. So I mean, just like this, where's the runner? Yeah. So all you wanted to do, was drive, right? But you had to create a car, you had to create the engine. I mean, as a driver, just think about it. Your aim, your goal is to just, you know, go to somewhere and drive. But that's because you're a driver. But I mean, with the current design that we have right now, why is this taking like 1 million years? With the current design that we have right now, you have to first create the engine. Oh, you have to first create the car. Ah, damn it! But to create the car, you have to add an engine, and then you have to go and find the seats, and then find the frame. Then you put it together. Of course, this is not going to work because exactly, bridge go they blow you. There's no seat. Like, oh shit, you forgot to add the seat. Okay, cool. You now go into driver, and you're gonna, and in this way, you're actually even changing the, sorry, seat is equal to, actually this should be wrong though. Oh, bridge go to, there's no frame. Yeah, is equal to, you're like, oh damn it, I forgot to add a frame. You now go and add a frame, and then it works. Where's run? You then go and add a frame, and then it works. But it really doesn't make sense. Okay, and then they say, you know what? We also want to support some other type of engine, right? So you're like, okay, cool. They said they want to change the engine. Okay. You don't think, and you're like, okay, cool. This engine, the engine will always report, you know, current mileage. Actually, you know what? Let's add another engine now. Does anybody know another type of engine? Let's say diesel engine, and the mileage for this is like 1,000 already. It's not a new engine. So they say, okay, you know what, want to support a diesel engine, and then you're looking at it like, okay, does that mean, because this says public V8 engine, does that mean I'll create a new type of car? And then you're like, okay, you know what, I'll create a new type of car, which is a diesel car. And the diesel car, we use a diesel engine. We use a diesel engine. Okay, like, okay, cool. Driver. Now you want to drive a diesel car. Like, so at this point, you're just like confused. So every single time you want to make changes, you have to go in there. You have to, again, you're already disrespecting, or you're already messing up with the rule that says don't repeat yourself. If you go into the engines, they all have a function that says, you know what, current mileage, right? Same thing with the V8 engine. You can get the current mileage from the engine. So at this point, you're like thinking to yourself, okay, cool. I'm seeing a pattern here, right? You're seeing a pattern here. So you're like, okay, cool. You know what I'm going to do? I am going to create an engine interface. And this interface will have current mileage. And then I'm going to get rid of all these different types of cars, because every single car has the exact same logic. You know, it checks whether you have an engine, a frame, whether you have seats, and it says, you know what, this is I'm gonna get the current mileage, and that's me riding a car. It's just something simple, right? So you're gonna get rid of this. So let's also go back to engine, and let's create some instances of this engine, right? So public static final diesel actually, this is for static final engine. Let's go to the new engine, and the diesel engine will return 1000, right? So you create new. Okay, let's leave it like this. So now you have a diesel engine. Diesel engine. You also have so you can create 2 different instances of this without issues. You have a V8 engine, returns 0. You have a diesel engine, returns 1000, and they all conform to this interface, which means you don't need different classes for this anymore. So you don't need a diesel car. You don't need a special diesel engine class. You can just come in here and replace this with an engine, which is an interface that says, current mileage, which is perfect. You don't need any of this anymore. And delete it anyway. And what that means is that, but you still have one problem, right? This is still hard-coded. This is still hard-coded here. Okay, at this point, you're like, what engine would I supply to this car? And you have this problem because you have a configuration. I mean, so a car works with an engine, right? But then the driver has to know which engine it is. So it's one of 2 things. You're either passing in an engine here. You either say, you know what, I don't want to worry about this. I'm just going to pass in an engine. And then I'm going to use the engine here. But then now you've created another problem, which is the person that calls this method has to, okay, what engine am I passing? Which kind of doesn't make sense, right? And the reason it doesn't make sense is because you only took the problem away from the body of this drive method, and you give the problem to whoever calls this drive method. And you can keep going back and back and back. The problem is still going to remain, which is you have a configuration and you are trying to create, this configuration. So basically, this driver now has to know the rules that says, you know what, use a V8 engine or use a diesel engine. But that's not his responsibility. He's just here to drive a car, right? So also, you have this issue. Okay, you're like, okay, cool. What if whatever car you give me already has an engine, right? So this car has to have an engine somehow. So dependency injection says you should put this engine in the constructor. So what this means is that this car, by the time this car is created, it already has an engine, right? Oh, this is nice. This is cool. Let's see who is calling the constructor. Pom. This is red. So you still have the same problem, right? Which is this driver is trying to create a car. This car needs an engine, but this car doesn't, sorry, actually, I was supposed to do this first. Let's say this. So yeah, I mean, this way you've taken that problem out of there. But of course, again, you've introduced a new problem within car, which is that this engine is now hard-coded to diesel. Okay, how are you going to change this engine to a V8? I mean, it's, of course, at the end of the day, you're saying the real way to do it would be the way we just did it, which is we're going to pass the engine to the car. And then we're back in square one. We're like, okay, cool, we have to pass this engine, right? So all of these things is just, you're just creating more and more problems for yourself without using dependency injection. When you try to hard code things, it makes it so hard to change. So now you cannot use a V8 engine. You cannot use leather seats. You cannot use a plastic frame for your car. Let's say you want to make a very small car. You cannot use, oh yes, I even forgot tires too. You cannot say, you know what, I want Michelin tires. I don't want, I don't know any other tire provider other than Michelin, to be honest. Like, but basically, it makes it so hard to change. And when these requirements come, they are like, okay, you know what, just try and make it. It's not a small thing, it's just a different tire. But then you're looking at it like, oh God, it's because you have hard coded it in so many places, it becomes so much harder to change. And let's see how this is going to look when you use dependency injection, right? So there are some components in dependency injection. Let me see, do I have a slide for this? Okay, no. I don't have a slide for this, but I'm just going to write it here. There are some components of dependency injection, right? The first thing you have is the client, which is the object that needs a dependency. So we're just going to call it a client, right? The second thing, let's just call it a service, which is the dependency itself. Now, the third part of this is actually what you call an injector. And that's the next part I'm going to explain now. So all of what we have seen is, okay, cool. You know what, we're saying that let's first refactor this to use dependency injection. Again, we can pass it in any ways, but we can just say for car, let's say this car, by the time it's constructed, it already has an engine, it has a frame, it has a seat. Let's just leave it like this. This driver, by the time it is constructed, it already has a car. So this driver already says, you know what, I have a car. All I have to do, all I have to do is drive. Is ride the car, is basically drive, right? Let's also see where we're calling this. And this is the class that runs it. So we don't even, so let's just say we create a new driver and then we try to drive it, you know. We're going to run into an error here. And what does our error say? It says null pointer. And the null pointer is happening here. What this means is that car is null. And why is car null? Because we haven't assigned anything to car yet. So dependency injection says, you know what, this driver already has a car. This car already has an engine. It has a frame. It has seats. Actually, we can add a check for this so that we don't have a cryptic error message. I mean, this just says session in treadmill. It doesn't tell you what exactly happened. So we can add a check ourselves. Control new exception. Cool. So we go back to the runner, just so that we can see that that is exactly what is happening. Exactly. Car is null. So let's go back to our driver. So this injector is, so we've seen that, okay, dependency injection has said, you know what, this driver, in this case, the driver is the client and the service is the car. right? The driver needs a dependency of the car to be able to drive, right? The car itself needs its own dependencies. It needs an engine, it needs frame, it needs seats. It also needs a tire at the end of the day. Let's say for now, we're not using everything. We're just going to use engine, or let's just say, and then engine is its own interface that says, you know what, it's either it could be a diesel engine, it could be a V8, you know, that kind of thing. The driver says, you know what, I have a car. We can actually even take this further and say, the driver drives a vehicle. The driver drives a vehicle. Driver class, it's an interface. It's a vehicle. And this vehicle just provides a int, right, I think. Let's see. Okay, cool. So this is a vehicle. Why is it saying it's never used? Sorry. Vehicle to ride. Okay. Let's just. Oh yes, exactly. He has a vehicle, and the car is a vehicle. And the reason we are doing this is so that we can, you know, we want to be able to have like bikes. We want to be able to have scooters. We want to be able to have trucks or planes. You know, all of those are like kind of vehicles too. So sorry, implements. Jeez, and this should have a override if I'm not mistaken, and this should be void. Okay, I know that's why I did it now. Okay, it should be int. Cool. Okay, let's just leave it like this. So basically, we have a vehicle. I think I'll need to add this trans exception, and then so we have our car now. Cool, fine. So a driver will drive a vehicle, and you know everything should be. But so the reason why this is null is because nobody has set the vehicle, right? So this is what we want. This is the structure we want. We want to say, you know what? This driver already has a vehicle. His only job is to drive. This car already has an engine. It has frame. It has seats. His only job is just to return the current mileage, right? But nobody has set any of these things. And that is the job of the injector. Oops. Injector. Rename the file. Cool. That's the job of the injector. Basically, the injector is like the glue. It takes, you know, it's like the guy that says, you know what, okay, if I want to, this is where all of the instantiation and the creation and everything happens. So the injector can take parameters. It can say, you know what, based on the time of day, when you ask me for a car, I'll give you a scooter, I'll give you a lorry, I'll give you this. So let's just say that we have let's say this injector is also it has a bunch of factories, right? A factory in this case is something that produces something. So this injector guy is straight from the factory. You know, if you ask it for a car, it's going to tell the factory, okay, guys, well, this is the kind of car that this person is asking me for. I'll need seats, I'll need 2 tires, or I'll need 4 tires, or I'll need like a roof over the head of the car. So just for, you know, testing purposes, let's just say that when you say injector, public static void, public static fine now. No. Anyways, public static get car. Let's just say get car, right? And this should return, actually get vehicle. Now let's just give me a vehicle, right? This will give you a vehicle. So if system current time millis modulo 2 is equal to 0. So we are going to return, actually not, let's say to get you a vehicle, we'll need an engine. So engine engine is equal to engine.v8, or else engine is equal to engine.diesel, and then car okay, we're going to return cool. So the injector is, so you're saying you ask this injector and say, you know, give me a vehicle, and it will return a car for you. You ask this injector, give me, actually, you know what, give me an engine. If you say give me an engine, it's going to return this engine. So if you say give me a vehicle, cool. All right. So the injector is the guy that that kind of like ties all of this together, right? This is the guy that you say, you know what, injector dot give me a vehicle, and it will give you a vehicle. So, and then lastly, public static driver. Actually, we don't need this because the driver is our what's it called? So if we go back to run, what this means is that so for every driver, we have this driver now, and like I said, you have to assign the car. Oops, driver dot vehicle is equal to injector dot give me a vehicle, and just like that, you encapsulate the logic of creating vehicles. So for us now, we are saying that this method system.current time millis, let's check it out. It says it returns the current time in milliseconds. So, which means if you call this at any point in time, it should give you. So what I'm doing now, if you do modulo 2, you are taking the remainder after dividing it by 2. So basically, this is kind of like odd versus even. So if the current time in milliseconds is odd, it will give me a diesel engine. If it's even, it will give me a V8 engine. That's just the logic. So I'm just training some very abstract business logic, which is, you know, based on the current time of day, you can either, you know, return a V8 engine or a diesel engine, right? So depending on whenever you call this. So if we run this now, everything should work. Yeah, we don't have any, you can see that it ran, let's just print. Let's print driver.drive. So let's return this. So so this is the mileage, and then we can also print on. I think that is system dot out dot print line the mileage is plus mileage. So let's try this one last time. If we run this, the mileage is 0. So if we run this multiple times, we should see, it's exactly, the mileage is 1,000 now. If we run this multiple times, we should see between 1,000, 0, 1,000, 0, 1,000, 0, like exactly. So basically there's like a probability of hitting, one or the other. So this is dependency injection in a nutshell. Again, there's always a client. As you can see, the driver doesn't know anything about this vehicle, right? He doesn't know how to create his vehicle. All he knows is that, as a driver, if you tell me to drive, I make sure. So this is an assertion. This is saying, I make sure that I have a vehicle, and then I ride my vehicle, right? Same thing with the vehicle. If you say I should be reading, I make sure that I have an engine, I make sure that I have a frame, I make sure the seats, I make sure that there's a seat, and then I can ride myself and I can return the current mileage. Now the fact that we are having all of these checks here, the reason why we have all of these checks here is because we are using field injection, right? It's because we're using field injection. And field injection is exactly what we have, where we say, car.frame is equal to this. So we've created the car, and we are now, assigning it here. And again, this is not the best. This you can do this when you don't have access to the constructor. So when you cannot change the constructor, that's when you use this. But if you can change the constructor, you can always just go ahead and change the constructor. So let's do that real quick. There's IntelliJ has a straightforward refactor for this. Cool. And then we can move all of this into this guy. Yeah. So which means at the point where we are constructing this car, oops, let me see. Actually, this should be a runtime exception, sorry. That's why it's giving us all of these errors. Yeah, that's why. Okay, cool. Cool. So we don't need all of this. So if you set it as a runtime exception, it's going to, you don't need to check it. It would throw at runtime. So this way, we say, you know what? This car, by the time we construct this car, is going to have an engine. It's going to have seats. It's going to have a frame. Is this right? Oh, it switched. Oh, man. Okay, let's just do it manually. Okay. And then we can inline this. So cool. So when you say give me a vehicle, this would, it would create a car with an engine, a frame, and just one seat in the array of seats. So this way you have all of the checks very early, and when it comes to time to use the use the dependency, you just call it directly. It's pretty straightforward, right? So same thing for the driver. So we can refactor this to add the vehicle as a constructor parameter, and that way we can also make sure that this vehicle is not null. So if vehicle is equal to null, throw a on-time exception, or that the vehicle is null. So again, you can just say create a new driver with the vehicle, and then you can always drive and print out the mileage, right? So at the end of the day, this is the idea of dependency injection. I kind of ran through it very quickly. So if you have any questions, like I said, you could always stop me halfway through the middle. But at this point, I'm going to give opportunity to ask me questions also. So if you don't understand the reason why I did something, please feel free to mention it. If you also think, and it's not just questions, if you also say, if you also want to say, okay, cool, that this is fine, I totally understood what you did here, like comments, any suggestions, any questions. If you're confused, just let me know at this point. So
sorry, please, while the rest are asking their questions, I would like to see that vehicle interface. Sorry, the engine interface,
all right. So this is engine. So actually, I can take this out so that it doesn't look very bad, right? Okay, I'll put them back at the bottom here. So what this means is that the engine is an interface that has just one method. So which means implementations of this engine, will override this one method, right? So
yeah.
we have two implementations, diesel and V8. So the fact that they are inside the engine interface means that you can say engine.diesel. We could create their own special classes for this. Let me see if there's a quick fix for that. Let's see if there's a quick fix to create special class, replace with lambda, to string, copyright. Okay, so I can't see any quick fix to create a special class, but we could always have said, you know what, static class diesel engine implements engine. Oh, sorry, not static. Oh, wait. No. Oh, yeah, exactly like this. Yeah. So something like this, we could just say, you know what, diesel engine or V8 engine, right? What's wrong here? Huh? Yeah, this thing should be static though. Okay, I mean, of course, we could also define them in their own classes. I'm not sure what the issue is, but basically what we did is we just defined two implementations. If you put a variable within an engine, within an interface, sorry, it is automatically static, right? So yeah. But you know what? I can move these out into their own classes. I think it might be better for understanding that way.
No, I actually kind of understand it because I quickly had to go and do something, so I didn't see how you implemented the interface. That's why I wanted
Okay,
you
okay,
to
okay, okay. Yeah. So right now, I mean, the interface is just a simple method that says, give me the current mileage for diesel 1000, for V8 0. Something simple so that we can be able to proceed. But of course, a normal engine would have a lot more methods. You have like parameters, sorry, to have like properties like fuel gauge size, like all those kind of things, cylinder size, radiator temperature, just it will have a lot of things. And that's the good thing about dependency injection, right? It scales. And what do I mean by scales? This is a very simple case, and we can already see problems if we have like multiple. So if we have like 10 different types of engines that we want to support, or our drivers we have like different types of drivers that can drive different type of vehicles. So let's say we have a specific class for a driver that can ride scooters or bicycles, right? When the scope, when the yeah, let me just use the word scope. When the scope of the business gets very wide. So just imagine Uber right now. Uber has a lot of data. Uber has, Uber, their driver object is definitely not, driver.drive. No, the driver object has a name. They have rating. They have how many 5-star rides they've taken, and of course on the road he has like a location. He's always sending location to Uber servers, and like it's basically real world applications are very, very complex, and things like this, things like hard coding, dependencies, and things like hard coding dependencies, they kind of like stack up. They it's what you call technical depth, which is like things that are making your work with the code base, your work with the code much slower. So dependency injection helps you preemptively. So it helps you while you're designing the classes. It helps you while you're actually writing the code to preemptively get rid of, tech, or at least not introduce technical debt, which is like DE. Let me just spell it. So technical debt, right? So it kind of helps you, like I said in the slides, helps you, it helps you have independent objects. So for instance, this driver doesn't need to know what type of vehicle this is. The vehicle is an interface. All he needs to know is that if you give me a vehicle, I know that I can ride this vehicle, right? So for instance, if this driver became an interface and we had different implementations that says, for instance, a scooter driver. If you want to say a scooter driver can only drive a scooter, then in the drive method, you will now say, okay, if vehicle is, instance of, so if vehicle is not an instance of scooter, it's not an instance of scooter, then let's throw an exception that says, you know what, this is not a, so all I'm saying is that if you have a scooter driver that wants to drive a vehicle that is not a scooter, the guy will say, no, I'm throwing an exception at this point. This vehicle that you gave me is not a scooter. I cannot drive this, right? It also allows you to have like a very what's it called? A well architectured application, basically. So at the end of the day, of course, the questions you have to ask yourself are, okay, what are dependencies and what are not? So for instance, now I can show you an example. Let's say, for instance, this driver also needed to print a receipt, right? So let's just say he's gonna print a receipt. He's gonna print a receipt, which is gonna do system.out.println the receipt with the vehicle name. So let's just say a vehicle also has a name. So let's say every vehicle has a name. So this car, we're gonna override the name to return just a simple car, right? So we can say this guy is going to print receipts for, and then we do plus vehicle dot name. So let's say this guy prints a receipt that says, you know what, receipt for vehicle name. But also, we also want to do some formatting, right? So we have a format string. Sorry. Yeah, actually private string receipt format is equal to, so let's say this is receipt for this. So this is the format of the receipts. How do we format stuff in, I think it's called string.format. Okay, yeah. String.format, yeah. Receipt format with the vehicle name. So let's say we have this receipt format that says, you know, receipt for this. So I'm going by the assumption that you've done like basic Java. So you should know that we can format a string with another string. So basically what this is saying is that this string, when you pass it to string.format, is going to replace things like this with the arguments that you passed, right? So like I was saying, of course you now have to say, okay, what exactly is a dependency and what is an internal like a service or just internal part of the object. So for this driver, right, for the driver class, let's say the receipt format is not going to change, right? It's not going to change. If it's never going to change, or if initially the receipt format is not going to change, I can field receipt my final. Let's make it final. What else? Field can be converted to a local variable, of course. I'm just going to leave it here for now, just to prove a point. Yeah, if this format is never going to change, then it's not necessarily a dependency. The only dependency of this driver is the vehicle that he's riding. He already, let's just say he already knows the format in which he's going to print the receipt. But if in the future, this it's possible that different drivers will have like different ways they are going to print this receipt, or different formats for printing this receipt. So a car driver is going to say, you know what, thank you for taking your ride with me. This is your receipt. But a scooter driver will say, thank you for, no, a scooter driver will say, your ride was completed. This is the receipt. If that is something that can change, then this becomes a dependency of the driver class, and you can then move it. Oops, you can actually command control. Oh, sorry, it has an initializer. That's why. And then you can move it into the constructor. Oh my God. Okay. Let me just add it like, what the fuck? You know what? It's whatever. Yeah, and then you can move it into the constructor. Basically, at the end of the day, you just have to ask yourself what exactly is a dependency? What is this something that can change, or is it something that I would need to be able to change? Most likely, if you have anything here, it's actually good practice to just pass it into the constructor or pass it from somewhere else. That is dependency injection best practice. Just pass it from somewhere else, from some form of injector. That way, you can always change it later. So when somebody says, you know what, I want to change this thing. So initially, if we notice, this receipt started out as a hard-coded receipt format. And then somebody said, you know what, for scooter drivers, we want to change the way they print receipts. And for car drivers, we want to change the way they print receipts. So then we had to go into this class and start pulling it out, right? I mean, there's different ways you can do it. You can always say at this point, oh, if this is instance of scooter driver, why do I keep typing scooter driver, then receipt format is equal to, or else if this is instance of, but that means anytime a new type of driver comes, you have to come into this thing and add another else branch, and then come in here and add another else branch. Like, it doesn't make sense. Instead, if this was passed in via the constructor, or if this driver did not know how it got this receipt format, all it knows is that it has a receipt format. It will just use the receipt format. It makes it easy to reason about driver, because all you have in this method is just this. It's just this. This receipt format is going to come from somewhere, from somebody, which is usually the injector, right? So that's just the long and short of it. It's just, of course, it will take some time, it takes some practice, but it has to be like, just be deliberate about it. Ask yourself when you're writing a class, okay, what does this class need to do what it wants to do? And am I creating it within this class? If it's creating it within the class, okay, is there any way I can pass it from outside? Right? Is there any way I can pass it from, from somewhere else? So real life dependency injection is actually a lot more complex. Let me see if I can show you something. Don't be scared. There is nothing to be scared of, but this is kind of like real life dependency injection. This is a constructor. This class needs a service area. It needs FAQs, frequently asked questions. It needs how it works. It needs loyalty user service. It needs the reward service. It needs an actual service area. It needs an event logger. It needs an exception logger. All of these are passed in via the constructor, and then they are used. The good thing is there are things called dependency injection frameworks that help you not to manually write, because right now in this project we are writing our injector. We're writing our injector very manually. So injector, give me a vehicle, you know, injector, give me an engine. All of this is manually written. In a much bigger project, you're going to use a dependency injection framework that makes it easy to do all this sort of things. So for this one, all we're doing here is annotating it with inject, and we're telling it, okay, inject this constructor. We are using Dagger, which is a dependency injection framework for JVM and Android. It's pretty complex, but when you get the hang of it, it's actually easy to use, because if I want a new dependency in this class, all I have to do is just add a new constructor parameter, and that's all. I'll have a new dependency. Of course, there was some setup. There is some setup. Dagger loyalty component. There is some setup, but basically what Dagger does, it will generate the code that you write. So if you look at the path of this is saying build generated source. What Dagger does, Dagger generates the code that you normally write for injector. So let me just show you very quickly. Get rewards presenter. Okay, this is it. So get rewards presenter. Let me do something. I just want to show you that this generated code that you will normally write. This is still code that you write normally. So you see, when you say get rewards presenter, so this function is called whenever I ask the injector, I ask this. So in this case, this injector, in our case, which says, you know what, give me a vehicle, give me this. That's the same analogy here. I'm asking this injector to, you know, give me a rewards presenter. It's going to create a new rewards presenter with all of these things. I say, you know what, get the FAQ service, get the how it works. We check all of these ones so they have their own dependency. So in this case, there's a software, Dagger, that generated the code that I would write normally. So in this case, what we are doing here is called manual injection. We are writing the code by ourselves. Oops, sorry. We are writing the injection code by ourselves. Of course, in a very large project, you cannot do this because it's going to get cumbersome, right? But that's why you have dependency injection frameworks like Dagger that would take the pain out of writing, you know, injection code for you. Dagger has a huge learning curve, so that's why I'm not going to introduce it today. But subsequently, I'm going to give you guys my contact at any point in time. Please don't hesitate to reach out to me. Please don't hesitate to reach out to me on maybe Twitter, anywhere you can see me online. Please don't hesitate to reach out to me if you are having issues with dependency injection, Dagger, or if you want me to review something, right? And all of that. So yeah, that's the gist of it. Just as a recap, we have a client, an object that needs something, right? You have the service. It doesn't have to be called a service, but it's just a term, which is an actual it's basically a dependency. Driver depends on the vehicle and the receive format to be able to do its logic, which is when you say drive, I'm going to take that vehicle and I'm going to write it. But before that, I'm going to print a receipt with this receipt format and the vehicle's name, right? These two things are dependencies for the driver. And the driver does not have to create them by himself. It doesn't have to create the receipt format. It doesn't have to create the vehicle. It's going to be given to him. As a driver, you're going to say, okay, this is your vehicle. This is the receipt format. Go and do the logic that a driver is supposed to do. So that's the long and short of it. So again, please just ask me any questions. I'm going to actually shut up this time. Do you guys have any questions for me?
I don't have a question from my end. I understand it now. The manual dependency injection you did.
Okay, that's good. That's good. It's a. Sorry, come again.
There's no question from this side. It was perfect clear.
Okay.
I got the hang of the manual.
Yeah. That's good. That's good. Taiwo, what about you?
He just sent me a message now that he's going to fresh. I don't know if he's still on.
Okay. That's fine. That's fine. At the end of the day, once you get the basic idea, which is you should not like hard code, implementations, then it's going to be so much easier. If you have access to the constructor, just pass it in the constructor. If you have access to like a field too, you can pass it via field or via a method. That's all fine. So let's proceed. That is dependency in a real situation. So yeah, okay. I think also I should give you a task to do. But basically, so at this point, I would like to know. I think I looked at your curriculum initially, and I saw that you have done retrofit, okay, HTTP. Like basically, you can communicate with like a backend, right?
Yes, you can.
Okay, good.
Yes.
Did you do any sort of dependency injection
No.
with that? Okay, so the thing is, so I'm just gonna guess that when you did like retrofit, so within your activity, you created your OK HTTP, you passed your OK HTTP to your retrofit, and then you use your retrofit to create your what's it called, your service interface, right?
Yes. Yeah, like that.
Okay, cool. So of course, at the end of the day, the only thing that your activity or your fragment or your view or whatever it is that you are putting that code, the only thing that you actually needed was that service interface, right? You want to call a method and you want to say, you know what, retrofit dot gets this thing from the backend or get this thing from the API, and then you call .enqueue on it, on response, on failure. The only thing that you needed for that is the service, but you had to create OK HTTP, you had to create retrofits, you had to, and after doing all of that, that's when you now say, okay, you know what, retrofit or create service, create your service interface. Now, the problem with that is, I don't know how many times you repeated that within your application. If if you would like to share your screen and you want us to go through it together, I'm also fine to do that, so that we can see. So I don't know how many times you created this thing. So let's just say you have 5 different activities, or you have 5 different screens, right? And each one of those screens needs to make an API call. Most likely you would have had to done, OK HTTP, builder, retrofit, get your service, and then make the API call. Or so basically, the dependency injection part of that is taking the creation of OK HTTP and retrofit and the service out of the screen. So and this is kind of like the homework. And if you If you've done it already, that's fine. You can also still share it with me, and we'll look at it together when we all have time. Or if
Oh,
sorry.
no, I thought you wanted, like, you were saying we can share screen now, or is it later?
Oh, and anytime if you want to share it now, I'm actually fine with that. But at the end of the day, what's the task?
I'm listening. You can go
Okay.
ahead.
So at the end of the day, the task is that if you have like okay HTTP retrofit, duplicated in multiple places, the task is to get all of that into one class that you call maybe injector or objects or something. I mean, injector is fine. Injector, and you should just say, what, injector dot get API or get something service or whatever the name of the class is. Injector dot get this internally within the injector. Get service is going to get retrofit, right? It's going to get retrofit, and inside get retrofit is going to get OK HTTP, and inside get OK HTTP, is going to create the OK HTTP. Within get retrofit is going to create retrofit using the OK HTTP, right? And within just like that. So if you already actually, we can look at it right now, and we can do it right now if you guys want, or you guys can take a stab at it, like
Sorry,
try your
I think
hands
I've
at
done
it.
something like that. I think I've not, but I'm just waiting for my Android Studio to come up. So I'll show
Yeah,
you. I'll
I've
share my
actually
screen with
done
you.
something like that.
Oh,
I
okay,
can.
that's actually good. So
Should
that's
I go
actually
first?
good then. Yeah, I mean, if you want to go, that's fine. I'm going to stop sharing my screen for a bit, and you can share yours. And of course, if you also like, you can always send me if you want me to review like your projects or something, or you have something you want me to review. You can always send it to me, or maybe Slack me your GitHub. Don't worry, you have my contacts. You can always ask me questions at any point in time. Okay. Nice. Nice. So this is basically it. So let me guess, your main activity depends on the aha, exactly. So this is actually on point, right? This is exactly what we're talking about. So this way, right? You don't have to have your the configuration is not like scattered everywhere. Is within one point, and that way, if it needs to change, for instance, if you need to change the base URL, you're not going to be changing it across 5 different places. You're going to be changing it just in one place. So this is exactly it. And yeah, nice. Is that the same for you, Jimmy?
Yeah. It's the same. It's the same.
Nice, amazing. It's always good. Yeah, exactly. API factory, get clients, get API. Perfect. So this is actually good. The structure is good, because this way, at the very least, you can already see the benefits. Funny thing here, when I started, I actually didn't do any of this way. I was always like duplicating, you know, okay HTTP, okay HTTP retrofit. Like looking back at it now, it just felt like stupid, because at some point in time I was like, wait a minute, I have this same logic in 5 different places. Why am I doing this? And then I took it. One thing, I didn't know anything about dependency injection then. All I did was I just knew that it did not look right. Like it was just too much work having to go and copy this and then paste it here. And then if you needed to change it, you just like have to change it everywhere. It would not make any sense. So you take all of that, you take that piece of logic, put it in a central place. There's a single place to change, and yeah. So that way, I mean, it's cool. You guys are on the right track. If you have any other questions, please definitely just let me know. I'm gonna continue sharing my screen so we can round up. Cool. So I was supposed to share some industry insights. I know you guys have questions that are not entirely technical. So have nothing to do with dependency injection too. So all of those questions I'm definitely here to answer. But these are some that I was specifically asked to share. What do employers look out for? The number one thing is competency. And competency means that, okay, can you do the work and can you do it well, right? As a software engineer, while it's not a regulated engineering field like civil engineering or electrical electronics engineering, like there's no software engineering body or something. There are still things that you have to do that the wider engineering community deem deem good for you to do. So of course, one of that is testing. Although you can early in your career, you can get away with like not writing tests, but you cannot get away with not writing testable code. So there's two different concepts here. There's testable code, and then there's the actual test that you write. And testable code means maintainable code. So which means dependency injection, which means basically, if you look at this now, if you look at the situation where at the end of the day, you have to be able to write maintainable code. If you look at a situation where you have a piece of logic duplicated everywhere, it is a nightmare to change that sort of thing, especially in big projects. If you just keep copy and pasting things from this class to this class and this class, and you tweak it, and then it's a nightmare to be able to change. It has to be more. It has to be more structured. It has to be more architecturally sound than that. So writing maintainable code is definitely at the top of the list, and that includes things like tests, because the reason why you have tests, testable code is most likely good code. Tested code is best code because, especially with the high test coverage, and test coverage just means that you've tested every single part of your app, like automated with an actual like written code test. So what do employers look out for? Again, competency. And competency is, you can write code. You can write like good code. You write good, well architectured code. You know principles in software design. So you know software design patterns. You know when to use them. Like basically you are technically adept. That's just one thing. Second thing, which a lot of people don't actually pay too much attention to, is communication. And this involves both spoken and written communication. You have to be a good communicator. Why? Because in software, a lot of people don't realize this early enough, but in software, the stakeholders are not just engineers. So and by stakeholders, I mean that like people that have a stake in the software, they are usually, majority are not engineers. Like majority are, business people that are trying to make money off of the software, people that are trying to sell the software, people that are trying to use the software. Majority of the stakeholders in software are not developers. So you cannot say, oh, I'm a developer, I don't need to know how to write properly. No, you need to know how to write and communicate effectively. If not, it's just going to be super bad. So that's another thing that employers look out for. Employers look out for, like, just very, very strong communications skills. And communication skills cuts across literally everything you do. trying to convince somebody to see your point of view without, riling up emotions, without getting angry, without getting the other person angry. It's purely a communication skill. Trying to even within the code, how you name your variables, right? They say in computer science, naming is hard, and that stuff is so true. You have to be a good communicator, both also how you communicate like technically to your peers too. So, I mean, for instance, you have like with like version control systems like Git and the rest, you have like PRs, you have like code reviews. If you don't know how to communicate within a code review setting, you might introduce bad blood just from telling somebody, oh man, I don't like the way you did this. Who knows? Maybe the person will take it as another type of way, and all of a sudden you see that that person has started to hate you in the office, and you guys cannot work together well anymore. Like at the end of the day, everything is just you have to be a good communicator. So definitely technical ability, communication skills. Um, what else do employers look out for? Uh, Drive, and by drive I mean like you have to be a driven person. Uh, what's the word to what's the word? Basically, they don't want somebody that they're gonna be chasing. They don't want somebody that's just gonna be, just sit down, wait. They give you work, you try your best to do it. When you're done, you sit down, wait. Like basically, nobody wants to micromanage another person. They want people with initiative. That of course, it's not saying that they're paying you 20 naira per hour, which means you're not gonna kill yourself. No, nobody's saying you should kill yourself for 20 naira an hour. I mean, you do your job, but you should not be the sort of person that will need micromanagement. And of course, that's also a skill that you learn over time. It's not, of course, you might have it now, good for you. Or even if you don't have it now, that's not a problem. If you are the kind of person that needs to be micromanaged, you need to be told, okay, this is what you do. That is totally fine. But over time, it's something that you should build upon, which is basically just try as much as possible to push yourself to do stuff. So if they give you a task, it's not something you shouldn't be the person that they'll come and be asking, okay, what's the thing? If you have an update, be proactive. Reports, okay, this is the update on this. This is where we are right now, that sort of thing. And if you need like a push too, if of course, actually, if you're the sort of person that still needs micromanagement, telling your manager or telling the person that would manage you to manage you, actively inviting the person to come and ask about questions is also being proactive, is also a good stuff too. So that's the third. What else? I mean, those are the only things. Those are some of the most important things that I can come up with now. Uh, that employers are looking out for. For the second part, building a career portfolio as an Android developer, what should it contain? Yeah, mostly it should contain just stuff that you like, basically apps that you. I mean, as a hopefully, hopefully we are in here for more than the money. But okay, so if you're in software dev for just money, that is actually totally fine, because I mean somebody told you that as a software engineer you can earn this and you can live a good life. See, that is absolutely fine. And it's true. It's true. Of course, like markets differ. So you're not going to be rich as the owner of Google. Nobody's going to be rich as the owner of Google, of course. But sorry. But yeah, oops, sorry, I was distracted for a bit. But yeah, basically it's just saying that you should be. So anyways, what should it contain? It should contain like stuff that you've done, right? You should have stuff that you've done. Even if you don't have stuff that you done, it's fine. But you should be able to show something at least. Like if you're in software dev because you want to create, then I mean, no, you should not need an invitation to create something. Uh, I mean, if it's something that you like doing, then just try your hands out at different things. Like come up with like some ideas. Even if you don't even have to come up with ideas, you can look at something that somebody else is doing and try to copy it. Is the exact same thing with art. Artists, what they do, they see something, they try to draw it, they try to copy it, and they publish it. This is my own take. This is my own version of this stuff. So you do the same. So basically, a career portfolio. I don't know. It's just like normal. It's just like normal stuff. Like you should be able to just show what you've worked on. So if you're working as part of a company, and you should be able to say, okay, while I was at this company, this is what I did, and this is how it affected the company. That's that's basically long and short of it. Like this is what I did, and this was the impact. This was the outcome. That's that's basically it. And of course, if you have like uh, and then one other thing that is also super important, don't hesitate to put yourself out there. And like this is not specific to software dev. This is for every single creator. Like no matter whatever it is you're creating, put it out there. Like show it to somebody, show it to your family, show it to your friends, show it to people in the community. Just put it out there, tweet it, do this thing, hype yourself. Like just try to enjoy what you're doing. If you don't have time for all of that, that's still fine. I mean, just live your life. Is like there's no pressure to actually provide a portfolio. Let me actually put it that way. There's no pressure to provide a portfolio, but if you have one, just just showcase it. Nobody will kill you because of like your portfolio and stuff. Anyways, last question: how do I find opportunities? Stack Overflow Stack Overflow, recommendations, uh, job boards. There's like basically it's the normal thing. Like most likely, like just either you follow job boards. So for instance, now when I was looking for a job, I was following Stack Overflow jobs. I was looking at some Intuit. Was it no, not Intuit. I can't remember the name of the place. Intent, like some in something job stuff, one very popular one like that. I was just and then I was just like scoring the internet. Oh, software developer jobs in this space. But it was mostly Stack Overflow because Stack Overflow is actually they're actually kind of big now, so they have a lot of like jobs and a lot of companies go there. So I saw Karim, I saw it on Stack Overflow, and then a bunch of other stuff. So I mean, finding opportunities is the same thing, is the same process with finding opportunities in other fields. It's just like either somebody's recommending you or you're searching for it and you're applying to jobs. It's the same thing. So I think that's it. And we're done. So if you guys have any questions for me, I will take them now. If not, I will share my details and you can always connect with me later on.
My first question is non-technical. It's actually a very funny question.
Olamide,
Is your
sorry, I
money
can't hear
stable?
you. I can't hear you. Sorry.
Oh,
I don't know if you can speak.
okay. No, it's not a technical question. It's just something I've been wondering. Can you hear me?
Yeah, yeah, but it's
Okay.
faint, but
So,
at least we can, yeah.
okay, is your name actually Money, like, or your nickname?
Yeah.
You
Money is
get?
my surname. Yeah.
Are you? Wow.
Yeah, Robo.
I've always been
Yeah.
wondering.
I'm
Money.
from
Okay,
Delta State to Robo.
okay, that's why.
You see, that's why. But yeah, money is my surname. Yeah.
Oh wow.
Yeah. Myself, I don't even know how the name came to be, but not them sabi. Any which way we move. So I should have actually put my details here, but actually I can edit it real quickly.
Okay, I have a quick question.
Okay.
So, like for a beginner, what do you think should be, how do I put it, the recommended span of time to actually get himself grounded with learning stuff that will make him confident in the job sphere.
I don't even think you ever be confident. So the best thing for a beginner to do is take advantage of all the opportunities. I mentioned HNG's internship. I think that's a great opportunity. I don't know why. Again, I am super grateful to Mark for helping me kickstart my career. Like Mark said, "Are you looking for a job?" On a tweet. One of my friends, Okwe, he's a software engineer now somewhere in London. Okwe, back then we just finished UI. Okwe sent the tweet to me and said, "Money, reply Mark." And I was like, I should reply Mark. Okay, no voila. I reply Mark. I do. Mark said, "What can you do?" I said, "I do Android." He said, "Okay, send me an email." I sent him an email and he said, "Okay, cool, resume like this, like this." That was basically it. Funny thing is that the app that I built in hotels.ng was never published. Like it never saw the light of day. Even up until today, hotels.ng doesn't have an app. But just the fact that Mark said, "You know what, come and build an app." And he had a designer at that point. We had a designer at that point, Mubarak. And even the experience that Mubarak got from designing the application also helped Mubarak too. He got a remote job with TopTal at some point in time, and that's because he was like designing for Hotels 10G too. So basically, one, take advantage of the opportunity around you. Two,
Okay.
work on something, no matter how small it is. Like at least I think for my first app, I was trying to do like a book library kind of thing. Like I was trying to download like books from the internet, free books or something. It was for some stupid app, but I mean, the more you work on it, the more you like write apps, the more you learn. And then also read. So so this second advice is write and read. Write and read means um, make sure you are writing apps, make sure you are always trying out new stuff, make sure you are learning, but also make sure that you're reading other people's apps. So GitHub has tons and tons of apps. People do apps for like small things. They use apps to like learn and stuff. GitHub has a shit ton of apps. Like just go there if you know somebody that you even the Google samples too. Like Google has like this GitHub browser sample. They have this MVVM, like architecture samples. They have some Topica app. They have Santa Tracker. They have Google I/O. The app that they use for Google I/O is on GitHub. So like go through all of those apps, read them. Like just keep reading. You have to write and you have to read. There's no shortcuts. You just have to keep writing and keep reading. And of course, take opportunities. And you can, if don't be scared to also actively search for opportunities. I don't think there's ever a time you think that, oh, okay, I'm ready to apply for jobs now. That will never happen. So just keep doing what you're doing, keep writing apps, keep reading. And okay, yes, there's another thing I want to add to. Um, of course, when I don't focus solely on Android too. As a software engineer, you benefit from learning, like from trying your hands out at like back end, or trying your hands out like design, or at least even if you don't actually try to code it, you might also benefit from like talking with people about it, or just even reading about it. So reading about backend things, reading about design things, reading about product management things, like basically just to make yourself a well-rounded engineer. So yeah, at the end of the day, take opportunities, write code, and read code. That's basically it.
Yeah, thanks.
All right, guys. This was way longer than it was supposed to be,
Thank you
but
very much. Thank you.
yeah, basically. So you guys,
I might be sending you an app to review probably on around Friday. Hope you
no
have
problem.
time.
Yeah, that sounds fine. That sounds fine. You guys, you can always send me. Actually, if just mention me on Twitter. Because I think my DM has like some. So Twitter has this thing where if you send a DM and I'm not following you, it would appear in some other place that I really don't check. So just mention me directly on Twitter, and I will be able to like reply you or anything. Also, I am on Dev Center. I don't know if you guys know about Dev Center Slack. I cannot get the URL right now, but
Yeah, I know about it. I'm on Dev Center.
okay, you can also send me a message. I think I'm a money on Dev Center
Okay.
Slack. I don't really check, but I check it from time to time. So maybe every like 2-3 weeks, once every 2-3 weeks. So it's much slower. But if you need like if it's not like if it's super urgent, you can always just mention me on Twitter, and I should be able to see it within a couple of hours. My GitHub is there. My GitHub is a graveyard of a lot of stuff. So, but you can always still just look through it. And that's it. Anyways, thank you guys for your time. I think this is I think we've reached the end of the
Thanks.
presentation.
Thank you
Yeah.
very much for your time. People want to put anything.
All right, guys. You guys should take care, and hopefully we'll connect more later on.
Right.
All right. Bye-bye.